Welcome to another video. Here is a quartic equations with x plus 1 raised to power 4 plus x plus 3 raised to power 4 equals to 16, and we're asked to calculate just x. But there is no ordinary x, so we have to find x. That is, we have to get 4x. And to do that, uh, we are going to use this short trick, and let's get started. If you let uh, x plus 1 equals to y, and this x plus y equals to y will make these equations easy, or we can still check for that. And by making y the subject, x, we are going to have y minus 1. So in the equation above, anywhere we see x plus 1, we replace it with y. That is y raised to power 4 plus bracket y for this one is we have x, which is y minus 1. We replace it as y minus 1 plus 3. Everything raised to power 4 equals to 16. So for here we have y to the power of 4 plus, here is y plus 2 raised to power 4 equals to 16. What are you trying to do? No, don't do that. Don't try to expand separate. So let's use this Pascal triangle coefficients. As if we have 1 here, we have 1, we have 1. And if you have 1, here is 2, here is 1. For here we have 1, 3, 3, and 1. Then followed by 1, 4, 6, 4, and 1. And that's how the series will continue. And what does this one mean is when the power is 0, here is 1, when the power is 2, when the power is 3, and the last one is when the power is 4. So we can keep it up like that, so till as many as power you wish. And I'm going to use the last one since the power is raised to power of 4. Let's start expanding. Here we have y to the power of 4 plus y, this one, y will take power of 4, 2 will take power of 0. So and that is 1. Here y will take power of 3 and 2 will take power of 1. That is, when this is increasing, this will be increasing. So followed by this, and followed by this, we have y and to the power 1, then 2 to the power 3 plus 2 to the power of 4. Remember, y has raised to power of 0. That is 1. And everything equals to 16. So for here we have, here is y raised to power 4 plus y raised to power 4. It has taken 1. Don't forget what we use above. Then we have followed by 4, alright? Followed by 4. Then we have 2 beside it. Then 4 multiplied by 2, that is 8. Then y raised to power of 3 plus, so followed by 6, and if you multiply 4 by 6, that is 24. Then y raised to power 2, then followed by 4 plus, here is 2 raised to power 3, that is 8. Then 8 multiplied by 4, and that is 32. So we have 32, then y plus the last one is 1, and 1 multiplied by 16, that is 16, equals to 16. So if these two 16 cancel each other, and here is y raised to power 4 plus y raised to power 4, that is 2y raised to power 4 plus 8y raised to power 3 plus 24y raised to power 2 plus 32y, everything equals to 0. And 2 is common to all this and y. If I take out 2y from here, we are going to have, here is y raised to power 3 plus 4y raised to power 2 plus 12y and plus 16 equals to 0. And here is more of quadratic, so we let 2y equals to 0, or we let the y in the bracket equals to 0. So by doing that, we have 2y equals to 0, and y raised to power 3 plus 4y squared plus 12y plus 16 equal to 0. And from here, it is clear that y equals to 0, but don't forget uh, we assume that x plus 1 to be equals to y. That is, anywhere we have y equals to 0, it means that x will be equals to minus 1. And x equals to minus 1 is one of the roots of that quartic equation. Let's see how to solve this. But what do you think? Uh, there is a short way of doing this. We call it synthetic division. We are going to assume another root and we start testing. So if that root is equivalent to this, then we are going to assume that root as the first, as the next root, which is the second one. So let's say we have x equals to minus 2 from here. Let's start putting it. If we let this one raised to power 3 plus 4 to the bracket of minus 2 raised to power 2 plus 12 into bracket of minus 2 plus 16. And what I'm trying to write here is a is minus 8 plus uh, a is 16, a is minus 24 plus 16. And here we have minus 32 and plus 32, which everything equals to 0. So which means s equals to minus 2 is one of the roots. Sorry, we are dealing with y, and y equals to minus 2. Okay, so if y equals to minus 2, which means if you are going to use synthetic division to find the other root at y equals to minus 2, so we create a lines like this, and we start taking their coefficient. And for the s cube, we have 1. For the next one, we have 4. And for ordinary y, we have 12. And for the last one, which is nothing, then we have 16. And here is how to go with synthetic. So this one that starts, we are going to rewrite it as 1. Then for the first, for the y equals to minus 2, we are going to multiply it with 1, that is minus 2. And we add 2 and 4 together, that is 2, all right? Then we have 2 minus 2 multiplied by 2 again, that is minus 4. Then we still add this, that is 8. We multiply this as well, we have minus 16. Then we still add this. And by adding this, we have 0. So when we get 0 here, 0 here is known as r, and that r is remainder. So when remainder equals to 0, then we are going to have the rest as quadratic. So since we are having third term here, but this y equals to minus 2, and from x plus 1 equals to y. So if y equals to minus 2, definitely the value of x here is equivalent to minus 3. So we have gotten 2 roots for the quartic equation above. And for this one, it is a quadratic. We have 3 terms here. So here is x squared plus here is 2x plus y here is 8. Everything here equals to 0. And we can solve this one quadratically, but this one is not factorizable, so we can use the quadratic formula to do this. And we are dealing with y. I just love x. I love x. I don't know why. And let's see how to go with this. The quadratic formula says if you have y equals to minus b plus or minus the root of b square minus 4ac, everything divided by 2a. We are going to use this formula. And how can we get all these parameters? So from this equation, a is 1, which is the quotient of y square, b is 2, which is the quotient of y, and c is the constant value, which is 8. And we start putting all these parameters in this formula, and y equals to minus, so b is 2 plus or minus the root of b is also 2, but this is having square, minus 4 dot a is 1 and c is 8. Everything divided by 2 dot 1. Let's evaluate this. We have y equals to we have minus 2 plus or minus the root of a is 4 minus 32 divided by 2. And from here we are going to subtract 4 and minus 32 from each other, and clearly we are going to have a complex root here. But let's see how we can get that. Y equals to minus 2 plus or minus the root of, here is minus 28 divided by 2. But if you have y equals to minus 2 plus or minus, I can separate this as root 28 multiplied by the root of minus 1, and everything divided by 2. What I use above is the root of such, and here we have, if you have root of minus 1 is known as I, and here is a complex root, so you can use any letter J, K, and any one you like. So I'm using I, and by replacing it in this, we have y equals to minus 2 plus or minus the root of 28I, then divided by 2 entirely. But this 28, when we simplify it, we have 2 root 7, okay, and that is the root of 28. So in a short form, then we have y equals to minus 2 plus or minus, then instead of 28 we have 2 root 7I, everything divided by 2. And since we are dealing with plus or minus, we are going to obtain the y3, which is equals to minus 2 plus 2 root 7I, that is along positive first, divided by 2. And y for the y4 equals to along negative, which is minus 2 minus 2 root 7I divided by 2, and 2 is common above, so if you take it out, we have minus 1 plus root 7I, and for the y4 we have minus 1 minus root 7I. But here is not the final solution. Don't forget we let x3 equals to x3 plus 1 equals to y3, and by putting all this thing here, we have x3 equals to y minus 1, y3 minus 1, and x3 equals to what is y3? That is minus 1 plus root 7I minus 1, and here minus 1, that is minus 2. The final result for x3 is minus 2 plus root 7I. So making 3 roots we have obtained. Let's see the last one. At x4 plus 1 equals to y4, and by making x4 the subject of the formula, we have x4 equals to y4 minus 1. And by putting this thing here, we have x4 equals to, and the y4 is giving us minus 1 minus root 7I. And by placing it here, we have minus 2 root 7I. That is the value of x4. So we have obtained all the roots for the quartic equation above. And let's see how to check if all these are really equal or not. I'm going to write all the root out. For the first root, which is x1, we get minus 1. For the x2, we get minus 3. And for the x3, we got minus 2 plus root 7I. While for the last one, which is x4, we got minus 2 minus root 7I. But I'm only going to text for x1 and x2, so they are easy to check. They are not going to give us a problem. And here is the question given to us. And let's see if x equals to minus 1. We have minus 1 plus 1 equals to power 4, plus here is minus 1 plus 3 raised to power 4. Minus 1 minus 1, that is 0. So, and here is 0 raised to power 4, plus here is 2 raised to power 4. Everything equals to 16. So x equals to minus 1 satisfy this. And let's see at x equals to minus 3 if it's also satisfied. We have minus 3 plus 1 raised to power 4, plus here is minus 3 plus 3 raised to power of 4. Minus 3 plus 1, that is minus 2 raised to power 4, and minus 3 plus 3, that is 0 raised to power 4, and everything also equals to 16. They're also true, so which means if these two satisfy, definitely the other root will also satisfy. You can do that, and you can leave it in the comment box. Thanks for watching. I hope you like this video. Subscribe to my YouTube channel and never stop learning.